Okay, we are working in the Advanced 2 textbook, lesson 11.2, examples 1 through 3, pages 472 to 473. Okay, they like to give us an inequality that looks like this. X minus 5 is less than negative 3. We need to solve this inequality. And you guys already know how to do this. We're going to use the same rules that we used when we solved equations. Instead of an equal sign, we have an inequality sign. So the first thing I need to do is isolate my variable. To isolate the variable, I need to get rid of this negative 5. I need to undo it, which means I'm going to use inverse operations. I'm going to add 5. And what I do to one side, I must do to the other. So these guys cancel, and I have x is less than, I have a negative and a positive, so I'm going to subtract, keep the sign of my largest number. So x is less than positive 2. Perfect. X is less than positive 2. Let's graph that. To graph it, the first thing I'm going to do is draw my number line. I want to put my target number in the middle, and I prefer to go 2 ticks to the right and 2 ticks to the left. Now, I'm going to look at my sign. My sign is less than. It's not equal to, it's just less than. So it's telling me I start my answer at 2, but 2 is not included in the answer. So I'm going to use an open circle. My answer starts at 2, but 2 is not included in the answer. Now I start with my variable. X is less than 2. Less than means everything to the left. So x is less than 2. Here, my solution set is everything less than 2. Okay, let's do another one. Y minus 6 is greater than negative 7. You guys already know how to do this. We need to isolate the variable. To do that, I need to get rid of this negative 6. So I'm going to undo negative 6. I need to use inverse operations. I'm going to add 6. What I do to one side, I must do to the other. So these guys cancel, and I'm left with y is greater than, I have a positive and a negative, so I'm going to subtract and keep the sign of my largest. So the solution is y is greater than negative 1. Awesome. Let's start with my number line. I'm going to put my target in the middle. And then 2 tick marks to the right and 2 tick marks to the left. Okay, now I'm going to look at my sign. My sign is greater than, but there's no equal sign. So that means my answer or my solution set starts at negative 1, but negative 1 is not included. So now I look at my variable. Y is greater than negative 1. Greater than means everything to the right. So everything to the right of negative 1 is a solution for this inequality. Okay, let's do another one. 13 is less than or equal to x plus 14. Okay, awesome sauce. I can do this. Let's isolate the variable. To isolate the variable, I need to get rid of positive 14. I need to undo it. So I'm going to use inverse operations. What I do to one side, I must do to the other. So I have a positive 13 and a negative 14. I'm going to subtract and keep the sign of my largest. My sign comes down. X, these guys cancel. So negative 1 is less than or equal to x. Okay. I'm going to start with my number line. I put my target in the middle. 2 ticks to the right and 2 ticks to the left. I'm going to look at my sign. My sign is less than or equal to. Equal to. So that means my solution set starts at -1, but it also includes -1. So I'm going to use a closed circle. But now this says -1 is less than or equal to x. When I'm graphing inequalities, in my head, I like to start with the variable. It makes life easier. So on paper in a book, this would be said, -1 is less than or equal to x. But in my head, I like to start with the variable and say x is greater than or equal to -1. It makes it easier to graph. X is greater than or equal to -1. Well, greater than means everything to the right. So when I'm graphing and I'm saying it in my head, I always like to start with the variable because it makes it easier to graph. So in this case, since the variable is on the right, I'm going to read it backwards. X is greater than or equal to -1. It's always easier to graph when you start with the variable. So let's do one more. 12.5 is greater than or equal to D plus 10. Okay, I know how to do this. I need to isolate my variable. So to get the variable by itself, I need to get rid of this positive 10. So I need to undo positive 10. I need to subtract 10. What I do to one side, I must do to the other. Okay, 12.5 minus 10. Can you use a calculator for this? Yes. If you need to, please do. So I'm going to subtract and keep the sign of my largest. Bring down my sign. These guys cancel and I'm left with D. Perfect. 2 and 5/10 is greater than or equal to D. Perfect. So let's start with my number line. I put my target in the middle. 2 ticks to the right. 2 ticks to the left. Now I look at my sign. It's greater than or equal to. So my answer, my solution set starts at 2.5, but it also includes 2.5. It's equal to 2.5. So it starts at 2.5 and it includes 2.5. So I'm going to use a closed circle. Now, in a book or on paper, this would be said 2.5 is greater than or equal to D. But since I have to graph this, it's easier to start with my variable. So in my head, I'm going to say D is less than or equal to 2.5. D is less than or equal to. So less than is everything to the left. So that means everything to the left of 2.5, including 2.5, is a solution. Okay. I want to set up one word problem with you. Now remember, when we set up a word problem, it's not enough to copy it. You have to understand why it's being set up that way, because you'll see it again as a CER. You're going to see this again as a CER. So make sure you understand the problem. Don't just copy it. Okay, we are on page 475, number 25. The hole for a bird feeder post is 3 feet deep. The top of the post needs to be at least 5 feet above the ground. Write and solve an equality that represents the required length of the post. Okay, first of all, I'm going to draw a picture. So here's my ground. Here's a hole in the ground that's 3 feet. Now the post needs to be at least 5 feet tall. It can also include all of this space above it. It has to be at least 5 feet, but it can be taller. So it can be 5 feet, it can be 5 feet 5 inches, it can be 6 feet, it can be 7 feet. It needs to be at least 5 feet, but it can be taller. Okay, so when I'm writing my inequality, my post can be greater than or equal to 5 feet. The post has to be at least 5 feet, but it can be greater than or equal to 5 feet. Okay? So that means it's all of this up above can be X. We don't know what height we're going to be. We just know it needs to be more than 5 feet. But we also need to include the part of the post that's under the ground. And when it's underground, it's negative. So everything above ground is positive, but everything below the ground is negative. So we have all of this positive space, which is X, but we also need to include this -3 that's under the ground. So this is all X, and then -3, we need to include that. And we need to make sure that this whole thing is greater than or equal to 5. Now, this is a problem you know how to do. We need to isolate the variable. So to do that, I need to get rid of this -3. To get rid of -3, I need to undo it. I need to use inverse operations, so I'm going to add 3. What I do to one side, I must do to the other. Okay, these guys cancel, so I'm left with X is greater than or equal to +5, +3. Positive pirates like to combine forces, so I'm going to add them and keep my sign. So my solution set is X is greater than or equal to 8. So an 8-foot pole or taller will meet my requirements. Let's graph that. I'm going to put my target in the middle. 2 ticks to the right, 2 ticks to the left. Now, my sign is greater than or equal to. So my answer, my solution set starts at 8, but it also includes 8. So it's going to be a closed circle. And when I'm graphing, I always like to start with my variable. I say it in my head. X is greater than or equal to 8. Well, greater than means to the right. So that means any pole that is 8 feet or taller will work for us. It meets our minimum requirements. So what does this mean? Any pole 8 feet or taller will meet our minimum height requirement. Okay.